Okay, we'll look at our final instalment for our index law series with index law 3. Now, index law 3 is a funny one where we're raising to a power. Alright, so where we're looking at brackets. Now, the brackets rule is anything outside the brackets applies to everything in the brackets. So that one is where I have, if I'm writing into expanded form, a times a, but I've got to do it twice. Alright, so a times a times a times a. And so then I'll go back into my index notation. That becomes a to the power of 4. A to the power of 3 is a times a times a. But I'll multiply it all by itself. Times a times a times a. 1, 2, 3, 4, 5, 6. Here, a to the power of 3, all to the power of 3. So I have a to the power of 3 times itself again. Okay, I'm multiplying it by itself 3 times. A to the power of a times a times a, a times a times a times a. So I get a to the power of 9. And last one, a to the power of 4, all to the power of 4. So I get that multiplied by itself 4 times. 1, 2, 3, 4. And I count all of those a's up, and I get a to the power of 16. And once more, I have a look now and go, okay, how do I skip this step? Because if I get big numbers, that's too many a's for me. I'm going to go with 2 and 2 to get 4, 3 and 2 to get 6, 3 and 3 to get 9, 4 and 4 to get 16. And it doesn't take a rocket surgeon to figure out that I'm multiplying there. So index law number 3 looks like this. It looks a bit funny. A to the power of m all to the power of n equals a to the power of m times n. So if I have x to the power of 3 all to the power of 5, right, I do that as 3 times 5 x to the power of 15. I can test it. 1, so I've got to do this 5 times. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Happy days. That's probably a better way to show it too, because you can look at, well, you know it's 5 times 3, and there we go. So again, 5 to the power of 4, 5 times 4 is 20. I'm not going to write that out because that's a lot of ink, but you can if you really want to. So I test that one, a to the power of 3, all to the power of 5. You should be able to figure out an answer nice and quick. And we end up 3 times 5 is a to the power of 15. A to the power of 9, all to the power of 6. Figure your answer out. 9 times 6, 54. Now when I get something like this, 3a to the power of 4, all to the power of 2. Now remember we said anything outside the brackets applies to everything inside the brackets. So if I do my little thing before, I have 3 times a times a times a times a, 4 a's, and I do that twice. 3 times a times a times a times a. Alright, and they're being multiplied. 3 times 3 is 9, and I have 1, 2, 3, 4, 5, 6, 7, 8 a's. So a to the power of 8. And I go back and have a look at this and go, okay, how did I get that? Well, I square my 3 to get my 9, so I do my numbers first, just like I did with index law 1 and 2, and then I apply my index law number 3. 4 times 2 is 8. Got to be careful with that. I'll do another one just because it's probably a good idea. So 5 b to the power of 4, all to the power of 3. So again, I do my numbers first. 5 to the power of 3. Well, 5 times 5 is 25, times 5 is 125, and then b, 4 times 3 is 12. Right. So it starts to get bigger and bigger numbers, but it's not that massive. And if you end up with something like, say you get something like, 7 c to the power of 6, all to the power of 8, you wouldn't be expected to go, well, what the hell is 7 to the power of 8? So you just write it like that. 7 to the power of 8 times c to the power of 48. 6 times 8 is 48. So that's how you'd write that one, unless you got your calculator and you're really wanting to work out 7 to the power of 8. You've got to be careful with ones like this, that they might throw in to trick you, because at this stage we're not working with algebra on this one, and that's the base number. So don't go 5 to the power of 6, because it's actually 5 to the power of 4 all to the power of 6. So that one is actually, oh geez, had a Barry Crocker, I was looking at the wrong thing, is actually 5 to the power of 24. So that one, you might want to have a crack at putting that in your calculator like that to just show why that's that, because, as I say, we're using that base number. We kept talking about that base number with index laws 1 and 2. So that 5 is being raised to the power of 4, then again to the power of 6. And if you wanted to write it out like before, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I've got my 5 to the power of 4, all to the power of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. What did I write it for? It's time to go home to bed. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So it is that 5 to the power of 24. So just be careful with ones like that. And so, but if you do have that coefficient has to be raised to the power first. So 2 to the power of 3, 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. See, 8 times 3 is 24. And now you are an index law expert. Congratulations.